Okay, so we've got our two equations. We talked about how it's a good idea to make both tables at the same time so we don't overshoot our answer. That means now we need to actually start making our table. So we need a table for each equation. So we'll set up a table for both of these. If we're making both tables at the same time, that means we're going to have to go back and forth a little bit. So you just have to be really careful which equation am I working with. Usually we start with the start value, right? Or we start at the beginning. So 0 is usually the beginning. So if I fill a 0 into this, 11 minus 3 times 0 is?
11.
Which makes sense because that's the start value, right? We could see it in the equation. What's the start value over here if I hop over to my other equation? Negative 1. So that's what I meant by make both tables at the same time. Do 0 for both. Are those the same? So then that's not the answer. So that means I want to move down to the next number and try that with both of them. So basically what a table does is it gives you an organized way to loop through the possibilities until you get to the answer. So that's not the answer. So now I have to try 1. What's 11 minus 3 times 1?
8.
Right? Which makes sense because my operation is minus 3, right? So I'm just going down 3 each time. What am I going to have over here?
2.
Yeah, because this operation is going up 3, right? Are those the same?
No.
No. So that means I need to keep going, right? So let's try the next one. Let's try 2 for both. So if I go to the next number in this pattern, what's going to come next? Yep, because it's going down 3 each time. What's going to come next here? Are those the same? Oh, so that means that's the answer. And remember,
Way faster than just doing it over and over.
exactly. It is pretty fast. So a couple of things on this. First of all, the answer was pretty early in the table. If I'd made my table go all the way down to 10 and did all of that before I started the second table, I would have done way more work than I needed to do. So that's where this tip of make both tables at the same time is handy. If what I'm just interested in is just the solution, I don't need to do all that stuff after I get to it. A reminder though, and this comes back to the landscaping problem, the numbers you found in the table, they were where the lines crossed on your graph, right? So this still is the intersection point on the graph. We're just finding it without graphing. So our answer still is a coordinate. So our final answer here would be, if I would have graphed this, the lines would cross at 2, 5.